Hello, everyone. All right, folks, hope you can hear me. I'm going to quick check with my side. Let me see. Okay, I think things are ready. Fantastic. All right. Perfect. Okay, folks, thanks again for joining this class. This is going to be very exciting. This is a first class we are starting here. This is going to be a long series that we are planning to do. This is our first class, and then I want you to, hear, listen, enjoy, learn, and that's a plan. And we'll probably spend 30 more seconds, and then I see a lot of crowd coming over there, so we'll probably give a few more seconds for folks to join here. So while people are joining, here's a quick logistics. And you can see the left side, there is a questions. And anytime you have any question, start typing, put it over there. And, uh, and then all of you can see the questions and you can upvote, downvote, and depends on the total number of upvotes, I will answer the question. And that's the one. And also there's a polls in the left side that's going to help us to figure out how we want to continue the sessions, more sessions in the coming days, and that's the one. And then also feel free to chat, and it's all kind of open to everyone, and that's the idea. And end of the day, here is the plan. We want to more focus on how we all can learn together. AI automation, there's a lot of exciting thing happening in the modern world today. So that's it. So with that, I think we have enough crowd now. Let's get started. So let's see. Okay. So, all right. Hope all of you can see my screen. Perfect. All right, team. So let's get started. Hey, this class is all about AI and the breakthroughs. But this, again, as I said, this is the first class in this series. The series is going to be multi-class series. We'll talk more about automation, RPA in the coming days, and then we will educate and explain all of the people here, whomever you are right now in your career later, maybe in your fresher and all the way you're part of the VP level, whomever you are, and how you can learn this AI automation, how you adopt it, how you push into the industry, and that's all the idea of this reason behind this series. And again, as I said, this is all free and going to be ever free, and the more sessions that are going to come, those are also free, right? So with that, today I'm going to more talk about the AI and the breakthroughs happening in the world. It's very exciting stuff. So with that, let's get started. Here is our agenda today. The agenda is simple. I'm going to break into 4 pieces. One is on the introduction side, quick introduction, AI, and many jargons around in the AI. I want to cut the noise and give you a very clear idea. What do you mean by AI? How you understand them? How do you keep the abstract meaning and get rid of all the other things? That's the idea of the AI. Second, the AI pipeline, how generally AI models are being built in a very high level. I'm not going to go detailed technical things. That's probably will come in the next few sessions later on. And then the recent breakthroughs happening in the world, and that's a third one. And that's again more exciting things happening. You all probably know in the media lot of things happening in the recent breakthroughs. Finally, the AI, and then move to the automation, right? So you probably get the theme. We'll start with the AI, we'll end in automation, and that's the shift, and that's the overall agenda. So with that, let's get started now. First and foremost, I want all of you to understand the basic elements of AI, how you will have an intuitive understanding about the AI, and then in general, the potential and the growth of AI, right? Now, let's talk about the very basic things here. One, AI and ML are almost same. However, technically though, ML is a subset of AI. But today we generally use both word all the time. So when I say AI or ML, kind of same. ML is machine learning, AI is artificial intelligence. Then when it comes to ML, people talk about varieties of types of the ML. I'm not going to go deep into that. However, in a very high level, people say, hey, there is a supervised algo, there's unsupervised, there's a reinforcement, but we're not going to go deep down on the technical side. And then there's a couple of keywords, the AI models. I'll explain more what exactly model meaning. and how you need to intuitively understand that. I'll explain that. And then AI model is different, AI algorithms is different. I'll explain that too, because AI model is the output of AI algo. So I'll explain that too. But you need to overall understand AI, ML all same. ML model means just a model, but then I'll explain the model part. Now, with that, again, this is all you already know, most of you, but just to refresh your, you know, understanding here. Today, AI can drive. My car can drive. Myself, a lot of your car can drive. AI can code. AI can draw. Today, AI can read and understand varieties of stuff today. And in today, in whatever the world you live in, most of your activities are being predicted by AI. AI can recommend, if you are in a part of TikTok, Instagram, AI can recommend varieties of contents to you, right? That's a lot of where AI is now into our world. So fundamentally, AI is eating the world, right? Previously, software used to eat the world, but AI eats software, hence AI eats fundamentally everything. And now, if you look at the AI growth, AI was kind of a little bit separate some time back, but now AI and automation come together. Automation, what happens? It amplifies the AI. Because if you look at an industry, they are all more focusing on the automation side. But automation is in a right now we are in a place where automation needs AI. So automation kind of amplifies the AI. And also there is a lot of open source happening in the AI side. And every organization today, if you look at it, there is an automation team or AI team. And how these teams are all coming today, where from all the way from the low level to high level, they have a COE on every company today to push this AI and automation. So there's a lot of AI growth happening overall. And then a more important, this class is all about, it's RPA plus automation focused. I'm not going to educate AI from a technical standpoint. I'm going to more focus on the AI from an automation standpoint. And then the RPA industry is a separate industry. It's a growing industry today. This RPA and the no-code tools, what happens? It become a catalyst to the overall AI growth. So now AI is being part of everywhere. And one of the reason is that also RPA, right? And that's the eye level. But you need to a little bit understand about the model. What do we mean by model here, right? As I said, AI, ML kind of same. What is the ML model here? So with that, I'm going to give you a quick example. This one, most of you know what is software function meaning. So let's start with that. You see a function that I've written here. It's very simple, a very simple third grade function. What it does is that it takes an input A and input B, and it adds together and it gives you a result. So the definition is called add. This we call as a software function. Software function is the basic building block of all of our apps and web apps and everything in the world today. Now, who wrote this code? Nothing but a software engineer, right? Software engineer, developer, anyone who writes a code. Now, this is very simple code. If you look at this, is the three things going on in this code. One, there is an input where the A and B are input. And then there is a one more is a result, which is the output, meaning the two numbers added together, and then that's the output. And there's the input and there's the output. And in between something happening, some operation happening. Here in this case, it's just addition, right? It's just adding the two numbers. That's all. This is the most simplest software function. And again, there is an input, there's output, and there is a result. Now, when it comes to modeling, right? I'm going to give you one more table here. Look at this table. Here, if you see there is an input 3 and 5, the output is 8. So now you get an idea. Oh, you know what? It's going to be nothing but addition. But if you look at the next example, 4 and 4 is not exactly 8. It's almost 8 though, but it's 7, right? And 2 plus 4 is 6. 5 plus 6 is not exactly 11, which is, it says it's 10 here, but the addition is supposed to be 11. Now, if you look at it, this input is almost addition, but not exactly addition. Now, this code is written by a software developer. But if I tell a software developer, hey, here is my input and here is my output, but can you write a function for it? This is a very tricky right now. You know why? Because it is not exactly addition, but it's a kind of addition. Now, in the software function case, the input was given by input and output together return is part of the logic. But in this case, the input and output is given, but we are trying to find the function, right? Think about again. The function is already there, input is already there, all you're getting is the output. So that's the normal standard software. But in this case, you were given a data set, meaning you are given the data, like what is the input and output. What you're expecting is that you want to write a function automatically. In other words, given this data set, you model this numbers, find the relation between input and output. And if you do that, and that we call it as an auto function, automatically you create the function. So you look at this, the same function here, which is written by any software developer. But here, the same function, but it's not written by software developer. It's created by machine by looking at the data set. This function, we call it as a model. Why? Because we modeled with this data set and we create a function here. And this is, I put it as an order function, but actually it is a model created by machine learning algorithm, right? So now with that, when we say model, what does that mean? Model means nothing but a software function. That's what you should understand from abstractly, very abstractly. Now, however, who built the model? The model was built by ML algo. But I'm not going to get into the ML algorithm right now. But what you in general need to think in a high level is that when anyone says model, they are simply talking about a one function. However, the function could be very complex though. Why? Because this was modeled through mathematical and probabilistic underlying data structure. Now, with that probabilistic structure, we could create a complex math formula behind, right? So that's why I put it as a black box algo, but it could be any complex math function. But in your high level, what you generally see is that, hey, you know what? A model means nothing but a software function. However, that function was created by machine. That's all. So that's how you should understand what exactly the AI model means. Now, the AI models are generally built by machine learning algo given a data set, right? So with that, I'm going to keep moving. And now you know what is machine learning model meaning, that anytime when there is a data set with an input and output, how you model it so that you create a software function is called modeling. Then that modeling generally has certain pipeline. Again, I say the AI pipeline, just modeling pipeline too. So there is a modeling pipeline as a series of steps. So let's talk about this one quickly here. So generally, as I initially said, you always take an input and then you take an output, and then you build a model. I can also give you a few more examples. Now take about the varieties of modeling happening in this world. Some of the modeling, for example, hey, given the image, you could predict the number of cats in the image, right? Now, given the image, predicting the number of cats is hard problem. You can't write a software code for it because there is no rules behind that. How do you write a rules? How to find the number of cats in the image? It's very hard problem. And that's where this machine learning comes in. Now, given a lot of data set, then now the machine learning will model it and it creates a function for you. With a brand new function, which we call it as a model, now you give a brand new image, it will give you how many cats in the image, right? So that's an example. Now we can count a lot of examples here. End of the day, there's an input, there's output, there's in between a machine learning algo. Let's say there's an image, then you can predict whether there is a face in it, right? Human face. Or given a document, you can say, hey, whether this document talks about games or politics, right? So varieties of examples can be given here. Now, once you have this data and you can build a model. So now any ML modeling has these four important functions. One is the data sourcing, like meaning in the image example, you get all the images. The data labeling is nothing but you're telling the actual output. So the data sourcing, I would call it as the input. data. Data labeling is figuring out the exact output. For example, in the images case, you take all the thousands of images, and then each image you go and say, hey, the number of cats is 2, the number of cats is 3, and then you kind of put all the label the each image. Now, once you have that input and output things for all the 1,000 images, and that we call as a data set. You pass it to ML modeling, and then you would get model get built. And once the model is ready, and that's a model function, which is an inference function or software function, nothing but a software function. Now, from that time onwards, you pass a brand new image, it'll tell you how many cats in the image, right? That's pretty much. So, but however, you can't write that function by standard conventional software coding. It's very hard problem to write it because there is no rules to do that, right? But this is all built by understanding, a mathematical understanding behind the distribution of varieties of things going on in the image. Now it would generally look at all the pixels and this and that, and there are varieties of modeling ways available. Some of the brand new modeling is called deep learning, which is a neural network based. So this modeling will go through, look at all the images and understand it, and then it builds a model for it. So that's fundamentally um, uh, modeling pipeline. Generally, this is the few steps, but again, each step can be divided into multiple steps, but I'm not going to go detail into that. Very high level, you can say, hey, I want to input data, which is data, you collect the data source. And also I want to output data, meaning I want to label those data, and I want to build the modeling, and then I want to get that software function, meaning the inference function. From there, you're good to go. You now call the function, you get the answer, right? With that, there are a few more technical keywords. I'll put that too. This together generally called as a data engineering, but also beyond that, um, you do data processing, because once you get a lot of data, millions of records, you need to do varieties of processing, this and that we call as a data engineering for machine learning side. And then also ML ops, it's basically a ML operation side. For example, um, when you start building a model, you won't stop in a one model, and you would start building many other models. Why? Because once you build a model, after some time, the model quality might deteriorate because there is a drift in the data set, meaning there is the data set and then the data labeling could change. Now your overall ML model quality might go down. So now you might building many versions of the same model. So you need to manage the versioning of the model, making sure you're the right model got deployed. So that's all comes under the ML ops. And then AutoML is another case where you can build the model end-to-end automatically. I'll come to that in the next slide in the more details. So again, these are all kind of words that floats around today in a industry, in the overall tech landscape. But I give you a big idea where these all words fit end of the day. But for you, in a very high level, all you need to understand is that there is a data set generation together. You pass it to ML algo, you get a model, and once you have the model, boom, there you go. Software function is ready. You can call the function, and then pretty much good, right? So now with that, let's say, how do you build a model? So now we talked about, hey, you just build a model here, ML modeling. But then now building a model, as there are multiple ways to build a model. One of the ways that you build a custom algo. So you need an algorithm to build a model. But do you have an algorithm? You may not have. Then the researcher and then the ML engineer sits and writes a brand new AI algorithm. But you know what? This is not happening all the time. This is probably top 3 or 5% cases. Generally, you don't write a brand new algo. Algos are already there. So this is the only a few top-notch research people are doing this one, the custom algo, completely brand new custom algo. But most of the time, what happens is that you will take the open source algo, which is a machine learning algo, and then you literally fine tune it, like reuse those open source algo. And then there are a lot of parameters that you need to configure, which is called a hyperparameter optimization. You do varieties of configuration by taking the open source algo and then reuse them. And that's how generally today we build it, like 90% of the time. That's how we build algo. So when someone machine learning engineer says that, hey, I'm building an algo, are building a model, it's not that they are writing a brand new algo. They're not doing that. They're fundamentally taking an open source algorithm, and then they kind of create a model out of it, right? Then the yet another way to build a model is that using a no code, meaning you, without any human intervention today, what happens using a auto NLP or auto ML, you can fundamentally build the end-to-end model. This auto ML software takes care of doing a hyperparameter fine tuning, and it creates a model for you. So it's basically a no code tools. And this is how it's kind of evolving. Long back ago, 20 years ago, I used to write a code, completely custom code. But then I started going here. Now, a lot of open source, and I'm no more writing any brand new algo. You won't believe it. Like 20 years ago, we were literally writing everything we need to write a code. But today, and everything become open source. We just take it, basically you fine tune it, modify it. But you need to have an understanding though, you have a clear understanding what's happening, then you can build algo. But now I'm not even doing this. I moved from here to here, no code tools. Why? The no code tools, in a one click, it builds a model for you. And then that's what we call it a auto ML, right? So this is how you build a model today. Now with that, let's kind of keep going. The third area which I want to touch is that the AI and then the breakthroughs. There are a lot of breakthroughs happening today. One is on the tabular data side, the other is the language modeling, and then the image processing side, and then also there's a brand new way of modeling, like unified models. The tabular data, I'm not going to look into a lot because this is something which kind of already solved many years ago. Now, when I say tabular data, it's kind of a structured data, kind of a matrix kind of data. For example, you want to predict a price of a home given the number of bedrooms, number of baths, and the square feet and all, right? It's a very structured data set, and you will try to predict the price of the home, and also maybe some more information, for example, the zip code where the home is and all kind of stuff. And nowadays there's a great open source code there. The problem is kind of mostly solved in that area. All kind of modeling can be built, and even then there is certain breakthroughs are happening. Now there's a deep learning based tabular data prediction is coming. That's pretty exciting thing going on. But I'm going to skip the tabular data part, but I will talk more about, let's say, the language models. Now let me go to the language modeling side, right? In general, the natural language processing. This is very exciting thing going on in the natural language processing. One is overall the text analytics side, like looking at the millions and thousands and millions of text. How would we understand what's going on, and then how do we figure out a sentiment out of each text? How do we extract the key items out of it? These are all varieties of things going on the natural language side. But long back ago, like 15 years ago, we were doing it in a different way. We were looking at counting the words, and then without even understanding the semantic meaning of it. Then there are many other ways to represent the word. The representation of a text itself is a hard problem sometime back. Then we had a varieties of breakthroughs. The breakthrough said that, hey, you know what, we can also take every text and we can convert the text into a a better representative, and so that it'll give you a more detailed semantic meaning of it, right? For example, there's a word cat, and then you don't take just the cat as a cat or convert into just one number, convert into a multi-number. We call it as a vector. So we vectorize that every word, and then each dimension of the vector will tell you the semantic meaning of the word. For example, the cat case, whether it is animal, whether it is a pet, right? So it gives you some idea about that each word. So what happens that's a kind of a breakthrough happened like 10 years ago. Now we have a much more a greater representation for every text. We have a more cleaner way to represent, and hence our all downstream AI models are getting much more better. So that's on the text analytics side in general, there are a lot of great things happening. Also, there's a language models, and that is you might hear about GPT-3 and all recently. These models, again, first of all, what is language model? It's very easy, right? Given a few words and you try to predict the next word. And then when you build that model, a high quality model, that's called language model. But the good thing about language model is that we don't need to build a data set because you don't need to label the why. You take literally thousands and millions of books and articles and everything, Wikipedia content, and you take every word and then try to predict the next word. Given a sequence of word, try to predict the next word. So when you, because you do have a data set, you can fundamentally build the model. The data set is basically free for you. Now what happens in the recently, the varieties of exciting breakthroughs that we could predict this word much better, much cleaner way. Now, hence, this brand new models, what happens is that it can even help you to write a blog, right? Write a blog, write a content, write a great stuff. It itself can create a content for you. But however, you need to prompt though, right? What is prompting? Like you will tell them, hey, you know what? I'm going to write a exciting blog. Let's say, for example, you write about automation. Hey, automation is on rise. This is exciting world. And then you say dot dot, and then it'll start writing for you what could possibly the next word and what could be possibly the next to next word, right? It'll write it for you. Now, that's the more interesting thing happening in the language model. But the language model also become a basic building block for all other modeling. Why? Once you build a language model, now using the language model, every word can be vectorized and it can give you much more better representation. With that representation, what happens? You take those and then you now try to use those vectors and do a varieties of text classification, text extraction, and you can build varieties of model. So that's a beautiful thing happening in the language. Now you take the language models, and then also there's the image processing going on. I'll cover in the next slide. But combine them, there's a brand new thing happening in the document AI side. What is a document AI? Now you take a large number of documents, either a PDF documents or web pages or Word documents, anything. And then generally, the web pages and PDFs are designed for a human reading, right? It is never built for a machine reading. So it is designed for us. Why we are visual animals, we look at everything visually, and we look at that table by table, para by para, and we read it and understand it. Now, when you want to build a AI to understand the pages and documents, it's not just the text. It's also you need to visually look at it and say, hey, where the tables are, where the images are, right? So you need to try to understand one by one, and then you build it. So now this document AI model, what it does, it takes the visual and cognitive and semantic, and then and also all kind of language models clubs together, and then now you build in a document AI. So with a document AI, now you can parse any complex document, invoice kind of documents, and all the way legal and any documents, plus web pages too. So there are many use cases in the document AI side. For example, you can understand a healthcare documents and then understand where the adverse effects are being talked about. You can go to complex web pages and understand about products and all those things. So that's the document AI side, right? So again, varieties of NLP breakthroughs happening, and there are many use cases for each one. So let me keep going through, and then also, folks, please type any questions. I'm going to answer those questions maybe end of this call, and then keep upvoting the questions. I'm kind of looking at the left side, and then I have a different screen here though, so I see some more than 3-4 questions coming here. Yeah, that's great. Please add more questions. Love to answer all those questions. Now with that, let's keep going here. So okay, so as I said, the image processing, it's pretty exciting area here. The image net to all the way, the video parsing, it's all going on, right? The error rate is, as I said, it's almost zero for the image net, and it's far better than human today. But from here, classifying the images and detecting the visual elements, from here, we now all the way move to generating images. This is very pretty exciting what's going on right now, right? Um, and then these are all, again, these are all like kind of brand new algos. But the interesting thing is that these brand new algos are, should you even remember it? That's an interesting question sometimes I am being asked. Not necessarily, because these are all comes and goes. This DALI is a one type of algo. 2 years later, you won't even remember it because there could be a brand new algo. But big idea is that this can create images, right? DALI is a one type of algo. Stable diffusion is yet another one. And what this does is that, given a small text, again, it's called prompting. You prompt and then it create a brand new image for you. For example, you can say, hey, create a bear eating donut. That's all. You just say that, it create an image, a bear which eats donut, right? Can you believe it? That's beautiful. Again, it is open source. Now it's there right now. You can go Google it, you can get it, you can try right now. A stable diffusion become the open source. DALI is not open source. A stable diffusion is a brand new algo again, and with that we generate image, right? And this one you should think about for a second, how exciting it is. Think about, compare with the for example, let's say Google. They have an image search. They have put a 30,000 plus servers. They have millions of images being indexed, and they are having an algo. And now you search an image, it'll give you an image. But this one, a model, just one model. That's it, one model. No 30,000 server, nothing. One model knows all about the world, how the world visually looks like, and it can create an image for you, right? So that is exciting in terms of generating images. So anyway, lot of interesting things going on in image processing. And then now modern way of building models are like unified model, right? We don't build models one model at a time and then we orchestrate them. We kind of build a model, clubbing all of them together, and then we generate a one unified model. The unified model is something not exactly new, probably last 1 year, 2 year there. You take all the way a variety of steps and then unify them and then build a model. So that's all. Many breakthroughs happening in the overall AI side. So now I'm going to keep going to the next area. This is where the more interesting thing coming, right? Now we all know the AI is there. AI become ubiquitous. AI is growing. AI is every day there is some state of the art news, right? Almost all the day. And we couldn't even keep it up on the space it's growing today. So a lot of things going on. However, there's a one perspective here is that AI adoption also happening because of the automation. And that's what I want to talk about that, right? AI and automation here. So as I said, there are many ways to build a models. And the one way is to, using a no code tool. And this is what happening in my side today. I used to build a code, literally writing a code. Then I moved on to start using an open source code. Today, I click and then I create a model. And that's what happening. Now, the no code tools are all over. AI models can be created without any human intervention, without any data scientist. And then also AI has become so ubiquitous, it's almost always there. That's on the no code tool side. And if you look at that, the RPA and then automation, what's happening is that RPA become a more standard industry. This RPA, many companies build this RPA softwares like last almost 10, 12 years. Using the RPA is robotic process automation. What it does is that it helps you to automate any mundane task and any task. But our RPA, by definition, it lacks intelligence. However, today many RPA tools are adding intelligence on the RPA part, right? And now when the RPA needs intelligence, where do you go? Obviously, AI is the one intelligence, right? Then AI can help RPA. Now, what happens? AI was growing independently one point of a time. Now RPA needed intelligence. So then now the RPA and AI coming together, and now it's creating a much more faster adoption. So that leads to the brand new area called intelligent automation. The intelligence coming from AI, automation coming from RPA, this coming together, so the overall intelligent automation is really rising. Now, even today, what I feel is we're just scratching the surface. We're on the tip of the iceberg. A lot can be done in this area because combining these two industries and the two technologies, that AI and also RPA. So now if you look at it from an automation perspective, right? So as I said, the intelligent automation is rising, but if you look at that automation, what are all the things we are automating today and where that intelligence, meaning the AI, is going to be very useful? So let's look at this specific slide here. Now, initially, when we tried to automate, we were automating the mundane task. What does that mean? Let's say you wanna open Excel and then the previous Excel and then copy some of the cells and put it in the Outlook and send an email to someone. That's just a mundane task. There's nothing much intelligence in it. You just open it, put it, send it, done. That can be recorded and then that process can be automated. That's the RPA part, robotic process automation. Those automation is easy using RPA tools. Now it comes to automating the decision making itself. How do you automate the decision making? So for example, let's say there's an email coming and from a customer care or from any of your customer, and you need to route that email to the right department to take decisions. Now that's the automating the decision making part. But that needs an intelligence though, because you need to read an email, understand the content and semantic meaning of it. Depends on the meaning, you need to route it to different places, right? But the previous one, automating the mundane task, you don't need any intelligence. But in the second one, you need an intelligence. And now this industry, this RPA industry, was growing and growing, and they were solved most of the mundane tasks. And then they came to the decision-making automation, and they are stuck. Why? They need an intelligence. But at the same time, the AI is growing much faster. So it's all is simply, put AI on top of RPA. There you go. You will get to know, you will automate all of these things too. So that's where this AI comes in picture, the number two. The number two can be automated only with the help of AI, with automation, meaning RPA, and then the AI part. The third part is that automating data capture. As you all know, data is end of the day, new oil, and you always need a lot of data, whether it's IoT, whether it's data from a web, whether it's data from a documents and images and videos and audios, you always need a data. Capturing the data itself is a intelligent activity. Why? You need to look at that, for example, image and understand what kind of things going on in the image, and you need to capture the data. Look at the web page and then read and understand automatically to capture the data. So capturing the data also become an intelligent activity. Hence, you need an AI there. So if you look at that 1, 2, 3, 1, you don't need intelligence. You just fundamentally record and automate it. But then the 2 and 3 needs a lot of intelligence over there. This is where the AI comes in and then adds it. But then the AI, once you put it on the top of the RPA, and then if you bring it together, it creates a lot of value though. And then because 2 and 3 is the high value automation. 1 also probably, but then that's not that high value. 2 and 3 really high value. And 2 and 3 also makes a loop. Why? To build a AI model, you need a data. So that means you need to capture the data first. To capture the data, basically you need AI. And then the AI needs data and data needs AI. So there's kind of a loop there, and then 2 and 3. And this creates much huge value. So when you want to automate, then 2 and 3 matters a lot. So once you get an idea, here is how you automate, then you can put that RPA and then AI combined together, and then you keep automating. Now, if you look at that, I started with this AI in the start of this class. And I'm kind of moving toward the automation. Why? Because automation is the one going to help to adopt the AI much rapid way. Now, This is where the paradigm shift happening, right? So if you look at inside your industry, you do not ask, hey, what AI you need to implement. It's kind of a irrelevant question. Why? If you are in a research side, though, you always ask the question, hey, you know what? I'm going to, figure out how the protein synthesis is happening, or I'm going to figure out how to, cure the cancer. These are all the research questions. You would more focus on the AI. If you're an industry, if you're an organization, you won't ask like what AI to implement here. However, you would always ask what you will automate in your industry, right? So the shift is that don't focus on the AI part, you focus on the automation part. So that's why I started this session with the AI, but then I'm going to end with automation because automation is what important. And for automation, AI is going to be extremely helpful. Now, here's the shift, and here's what you should do in the coming days. If you are working in any organization, whichever level you are, this is what you would basically go and ask: a what can be automated, right? That's what you're supposed to ask. What can be automated? And now the next question is that if you can automate the mundane task, it's good. You don't need AI, you don't need intelligence because you fundamentally record and automate. It's pretty easy, right? However, if you need intelligence, then your next question is going to be, hey, can we train and automate? When I say train, it's fundamentally machine learning modeling. Can we train and automate, right? So that's the second part. Now, if you can train and automate, then the third question is that the natural question is that do we have AI training tools? And obviously you can take machine learning coding, Python, and all. You can write a coding, but that is a little outdated today. Now, the next question, obvious question, is that hey, does it support no code model building like AutoML or one-click model building? And then not only just building the model, does it support the ML ops? Meaning you might end up with building varieties of models. How would you go through those and manage those models, right? And then the last but not least is that you all know the citizen-led developers are coming in this industry. They are helping overall economy uh, and pushing this industry to the next level. The RPA is another one. And can it support these kind of people? Because when you build a no-code model and your overall no-code software should be more intuitive so that RPA and citizen level developers can use those tools so that they can build a model and and hence they can automate, right? So the end goal is always automation. That's what I would say, right? End goal is always automation. How would you automate? How would you take it to the next level? So now as I said, this is the shift we all need to understand. It's AI. Yes, AI is so important, but AI is means, not the end. End goal is that automation. The means is the AI. So to have a great automation, you would ask what AI you want to build. And then for that, ask yourself whether you have enough tools and everything available. And if not, figure out the best tools, implement the best tools in your organization, and keep automating. And then that's how we can adopt this AI and also automation, right? So with that, I'm gonna pause here, look at a few questions and see what questions and I can answer. Um, I'm looking at my questions here. Okay, so one of the question is that what are enterprise? Okay, let me project that question. Okay. Okay, hopefully you can see the question now. What are enterprise use cases for AI to implement at organization level, right? See, the enterprise use cases, there are many, I would say. Let's think about in a few use cases, right? One would be, let's say in the manufacturing side. If you want to automate your manufacturing pipeline and you would put varieties of sensors in the IoT devices, and then you try to predict what machine's going to fail, what machines, how the quality of the products, and these are all one type of use cases where you would put literally AI and to make your product much higher quality and make your overall manufacturing pipeline more efficient. So that's one of the use cases. And then the other use cases could be that look at from the data capture perspective. As I said initially, as an enterprise, you always need a data. Let's say you want to know the competitive intelligence, what your competitors are doing. What do? You go to a competing companies' websites, and then you gather varieties of information. That can be completely automated today. Why? You apply AI, so the AI, the intelligent AI, can navigate, understand the documents, understand the web pages. You capture the right data out of it. The AI can helpful all along the way, right? So that's the data capture part. And also today, the AI is almost everywhere, from a sales side, in the functional level, the sales side, from the legal side, like for example contract management. There's a contract automation is one of the key today, where you take thousands and thousands of contracts, apply AI, read and understand all the contracts so that it can summarize for you nice and clean, right? So that's one of the use cases. So again, the question was asked by Shamir. Thanks, Shamir, again. There are many enterprise use cases there. Probably we can write more about that in the coming days. So now I'm going to go to a few other questions and see which one I can answer. Can we get a beginner guide for learning AI/ML? I currently work as an RPA consultant. Okay, right. So, okay, this is Parth Doshi. Thanks, Parth. So this question, beginner guide for learning AI/ML, work as an RPA consultant. See, this is exactly the idea about my series. And while I'm going through in the next few days, I will try to get some guides, and then I post it to for all of you. This is what exactly I want to do, right? My goal again, not to educate the software engineer. My goal is to bring automation consultants and RTA consultants, and give them enough idea how the AI works, and then how we build AI, and then and then take as part of the RPA. So that's what I'm going to do. So again, there is no direct right now answer. Yes, it is there. Beginner guide. We'll work on it. I'll probably create a separate post, and then I'll post it in either on LinkedIn or in some social media. So that's one. And then let's keep going. So I'll probably look at a few more questions. Any example which explains AI algorithm and AI model? So let me, again, that was by Shamir. Any example which explains AI algorithm and AI model? Okay. So as I said initially, AI algo is the one creates the AI model, right? Now, the AI algo, for example, a simple AI algo is called, let's say, the one of the algo is called XGBoost. It's a boosting algorithm. It's a one type of ensemble algorithm. So this ensemble was not a new, it's a very old one, like 15, 20 years ago. It was uh, invented. This algo, what it does is that it combines a multiple algo, and then it ensembles a multiple algo, and it predicts answer. The XGBoost and then the light GBM and all these are one type of algos. Using these algos, what you could do, you can quickly build any tabular data analytics, meaning you can predict one of the column given the other columns. That's the one example I gave. Given the data about a home, can you predict the price of the home? So that's a quick example what comes to my mind. Now, also the language model, the GPT-3 is a one type of algo itself, and also they built a model which is GPT-3 model. Then if you look at the algo, which is based on a model called transformer. So that's yet another model, and then using those models, you could build a varieties of language models. So that's another example. So I'm going to keep going to the next question. Hey, there's one more question. I don't know whether I have a right answer for that, but I'll still show you this. Asked by Srirang Joshi, which AI or ML tool can be used with RPA? I'm kind of being neutral in this class. I'm not, when I explicitly say, any vendor tools, unless otherwise it's open source. But however, I'll probably write a separate post for that. There are varieties of tools, by the way. AI tools and ML tools, which can be literally combined with the RPA. So I'll probably take it separately, this one. So I'm going to close this and let me see, is there any other? And meanwhile, probably I'll stop sharing the screen, everyone. I hope you can see me now. Hope the video is back. I'm not sure. Okay, so one more question. Let me project again. This was by Piyush. Is having in-depth knowledge of ML algorithms like regression, classification, SVN, etc., and statistics really necessary to utilize ML capabilities with RPA? You know what? Knowing that is always good, nothing wrong, but is it necessary? Not really. And now things have evolved a lot today. As I said, I used to write a code, as I said, long back ago, literally like neural network algorithm. Today, I do it everything in a one-click model. So you do not need to, but for curiosity, if you want to learn, yeah, please go learn. But you don't need to build, you don't need to learn everything to build models for RPA today, right? So let me close this and let's keep seeing, is there any other questions that I can answer? Which advanced level AI or ML tool can be used to the RPA? Again, as I said, I'm not going to talk about the tools right now, but advanced level, meaning that now in terms of advanced, I would say all the AI models are advanced, right? For example, the GPT-3 or Stable Diffusion, it's all are very advanced models that can be really used in the RPA. But when it comes to the tools, there are many tools available. But I would also suggest you to look at what it is of open source, and that many models already there out, which is open source models. You can look at those models too. So that's one question. So let me skip and then we'll go to look at the other. There was one more question by Sridevi. Can you share the sources to learn intelligent automation? Absolutely. I will try to source few um, areas, probably articles and maybe some videos. I'll share it to Sridevi. I'll do that. So we'll keep going to the few other questions. Okay, there was a reposting on question panel. Okay, let me see. This is from Gabriel. How AI-fused automation could help human in the loop, example, document understanding, insightful decision making, etc. A very interesting question. See, as I said initially, models can be built today with the no-code tools, right? Once the no-code tools build a model, now someone need to be in the loop to train the system. Two ways it can happen. One, there's a concept called, I mean, generally we call it as a human in the loop, but what kind of human, right? A data scientists are the one type of people, and then also the business people are other group of people. So I would probably differentiate into two: data scientists in the loop and business people in the loop. What does that mean? The data scientists in the loop, what do? They will just watch. They don't intervene. They just watch and see how this are all coming nice and clean. The tool will create the model. Then you use those model to score it. Meaning, for example, document understanding, you score it. Look at the answers. Then the data scientist would look at it and then they will kind of in the loop and they will just validate it and make sure whether everything is going good. If not, they will a little bit intervene to make the model much better. So that's one way of a human in the loop. The other human in the loop is that the business people are the data entry operators. What they would do is that they will again sit in the loop. They will, every time when the answers comes, they will say, oh, you know what, the answer is wrong. They will reject it. The answer is correct. They will approve it. While this is happening, the machine learning algo will get a much more cleaner, bigger data set. When the more data set and a cleaner data set is coming, the model will get built much better in a coming iterations, right? So hence this human in the loop automation or human in the loop overall system is much more important and famous in the recent years. And if you have a system where there is a human in the loop automation possible, I would always suggest please use that one. That's the best way to implement any AI super fast. Okay, all right, hey folks, there's a 2 more minutes there, and I would probably wrap it up. Maybe let's see, is there any other questions that I could quickly look at it and see? Again, now I see many questions. What is the best tools that can be used? I will probably write a separate um, uh, post for that. And okay, so I see. One is that what are the best tools for intelligent automation, which I answered already. Which advanced level I already answered. With UiPath, what AI model tools? Again, it's all about a tools question. So I'm gonna skip all the tools question and let me say any other question. What can be an efficient path to get into IPA for a data capture result? Should I start with the I, ML, RPA? Kindly suggest. So that is by Tejashwani. So this question, let me project that. So what can be an efficient path to get into an IPA? As I said, it's just all about starting with AI, ML, almost same as I said. Start with ML AI, understand the basics, and then start with some no-code tools, build some models, get an idea, and then also I haven't talked about more the math or the metrics behind every model, and then understand the metrics. That's going to be very helpful to you. People call it, hey, there's F1 score and the recall and precision. So learn about these metrics. That's going to be very helpful. Once you get a little bit of grip around this ML, you could build a model by yourself by varieties of no-code tools today. Once you get that, and then also it's a matter of how you can integrate with your current RPA tools to make any process automation much more intelligent. You make any RPA to automation intelligence, then you're fundamentally into an IPA world, right? So that's the answer for it, folks. This is great. Again, I'm gonna come to the time now, so let's kind of end the session. Thank you again so much for everyone joining this. And as I said, this is just start. We're gonna have many more sessions in the coming days, and also I need your feedback. Share your feedback, how you want to go in the coming days, what kind of classes you want to take. I have multiple ideas right now. We'll keep pushing. I'll also post it in LinkedIn. Follow me if you're not following so far. And that's all, everyone. Thank you so much again for joining this class. Talk to you again sooner. Thank you all. Bye bye.